In section 5.3, we're going to focus on a little bit different stuff. We're still going to look at binomial distributions, but we're going to be looking at finding mean, standard deviation, variance, and that usual versus unusual value. So how to find the higher end and the lower end for that. So these are going to be using formulas, and you will have to either have these memorized or put them on your one piece of paper that you're allowed that's handwritten one-sided. So that's what I would recommend. So the first formula that you need to know is that the mean, we're dealing with binomial distribution. So remember that the variables we're going to have, or the letters we're going to have to choose from, are n, p, q, and x. So our mean, mu, is going to be just n times p, according to this first formula. So we'll just do n times p. Now, to find variance, you actually do n times p times q. So you just take the mean and multiply it by an extra one. You multiply it by the q. As a side kind of reminder, remember p and q are complements, so they have to add up to 1. These are complements. Okay, well then how do you get standard deviation from the variance once you have the variance? How do you get the standard deviation? Well, remember, we used to do the reverse in a previous section, is we would take the standard deviation and get the variance by squaring it. So we're going to be doing the reverse. We're going to be going from variance down to standard deviation. So we'll do the reverse. Well, the reverse of squaring something is going to be square rooting. So all you have to do to get the standard deviation is square root the variance. So standard deviation is we'll just square root the variance. Then the next thing that we're going to do is, once we have the mean and once we have the standard deviation, because those are the two things we're going to care about, is the mean and the standard deviation, we will draw our little picture that we've been drawing, which we'll draw a little bell curve, and then we'll say what goes in the middle, which is always our mean. I'm going to start using our symbols, mu, so we get used to it. And then we find our maximum usual value by taking the mean, and remember this one, adding 2 standard deviations. Notice we're using sigma, so we're going to use sigma. And on the lower end, to find the minimum usual value, remember that we took the mean and we subtracted 2 standard deviations. So minus 2 of the sigmas. And that's anything that was in the middle, remember, was considered usual. And anything on the outside, on the ends, was considered unusual. So we're going to do that again, just now for binomial distribution. So we have to use the formulas to find both the mean and the standard deviation first. So let's take a look at an example. Assume the following examples yield a binomial distribution. So they flat out tell us it's a binomial distribution, so we know what to do here. Find the mean and standard deviation. Those are the first 2 things that they ask for. Find the mean and the standard deviation. So let's go ahead and work on those. Okay, well, the mean, mu, is just n times p. Well, they gave us those directly in the problem. N is 1,236, and p is 0.14. So our n is 1,236 times our 0.14. And let's see what we get for that. What we end up with is 173.04. And they'll let us know how to round in my math lab, so we shouldn't need to worry about that. The next thing that we're going to look at is then finding our standard deviation, which starts out with us finding n times p times q. Well, n is 1236. The p we already said is 0.14. How do we find the q? Well, remember the q here is the complement or opposite of the p. So if the p is 0.14, q is going to be 1 minus the 0.14, the rest of it, which is 0.86. And don't forget the last part of this is actually our variance right now. If we want to find the standard deviation, we'll have to take the square root at the end. So that means you need to do your 1236 times your 0.14 times your 0.86 first, which gets you right around 148.8144. Then you'll have to take that value and take the square root at the end. So then you'd say, well, what's the square root of that value? Well, that is about 12.2. Now let's go ahead and draw our picture. So let's draw our bell curve that we've been dealing with off and on. And remember, what's going to go in the middle is our mean, mu, which is 173.04. Then to find our higher side of our maximum usual value, we will take that mean and we'll add 2 standard deviations. So we will take this 173.04 and add our standard deviation, which was 12.2. We're going to add that twice to get the upper end. Well, let's see what that gets us. If we take the 173.04 and add the 12.2 twice, notice we get 197.44. And that's our high end for what we're going to consider usual. We still need to do the same thing, but for the lower end, which means we need to take our mean, which is 173.04, and subtract the standard deviation twice. Take away the 12.2 twice. And let's see what we end up for that lower end with. So we'll take our 173.04 minus our 12.2 twice, or you can just multiply it by 2 and subtract it. And we get a 148.64. So that'll be our lower end, 148.64. So anything that's in the middle here will be considered usual. Anything on the outsides will be considered unusual. So when they ask us to find the range of values that determine unusual values and usual values, this is what they're looking for. They want our minimum usual value and they want our maximum usual values. A lot of times they'll turn around and ask you a follow-up question on, let's say, a part B of the same problem, and they'd say, okay, well, what about the value 200? And you'd say, well, okay, well, the value 200 is outside of the usual range, so it's unusual. Or they could ask you about something like, let's say, 180, which is in the middle, which would be considered usual. So, but for this one, they just wanted the range of values, which is the 148.64 to 197.44. This next one,